So we mentioned problem domain consists of autonomous objects. This is something that begins to materialize very early. In fact, let me give you an example. Somewhere here we have a link to our sample project named Point of Sale. And Point of Sale is like your your supermarket type environment where you have cash registers, you have basically components of that, you have cashiers, you have managers, you have shifts of operation, you have sales that are taking place, right? So all of these terms, all of these, if you'd like to take a look at this and try to analyze it, all of a sudden you realize that some of these terms, some of this vocabulary that we're trying to use here actually contributes directly to a set of these autonomous objects, right? So if we would like to represent a cash register and the sale initiated on that cash register, if we want to represent individual sales items and their prices and everything, all of a sudden these individual pieces can be thought of as autonomous, kind of distinct objects. And that really helps to begin to analyze the problem and begin to think about, what's involved and where, how you want to approach implementation. Now, these autonomous objects exist in space and in time and interact with one another. It is kind of important to realize that objects have a life cycle, and the programmer has to be aware of the life cycle. Not all objects are created at the same time. That we pick the time when to create an object, when to give it its initial values. We will be able to recognize important stages in its evolution, and eventually we want to recycle it, or we want to essentially let it go and let it destroy itself, and so forth, right? So that is important consideration, that of course in order for objects to be able to interact with one another, they have to be instantiated and coexist in the same space and time. Now the space component of this portion of our conversation today is that the object don't have to, like for instance, again going back to computer memory, which is like really long array of memory cells, right? So we can have object A over here, right? We can have one object and another object over here. So we can have object A and object B, two different objects. They represent something useful, some kind of useful concept, such as employer, or department, or driver license, or thread of execution itself can be an object, and so forth, right? So but even on the same computer, the objects could exist and could belong to two different processes, right? There could be process A, process 1, I guess, and process 2, right? Two different processes. Let me just clean this up just to keep it kind of nicer. Process 1 and process 2, right? So in that case, it is no longer that trivial to be able to have some kind of method here, right? Let me just change the color here. Some sort of method that wants to execute, and that wants to, accessing, if this is method of process 2 and it wants to access object A, this is kind of trivial because it's in the same address space. However, it may be kind of non-trivial to be able to cross the process boundary and access object B. So on a computer, objects can exist in different spaces. A very standard solution to basically crossing this state is actually networking. Okay, networking. Because then if you use networking platform, then you can even separate this onto different computers. This process can be on one computer and exist in one hardware, and this can be another hardware computer. And so very standard approach to inter-process communication is actually through networking API, right? Of course, we could find different ways to do this, but networking and networking API is a very standard type of interaction in this kind of situation. So that's what we say here in respect to the space, that objects may exist even in different address space, different processes, or even different computers, right? So you have a client server, you have your browser running, and you have your web server providing you with information running. You don't even know sometimes geographically where that thing is. But still you can have the interaction, and as long as you provide the way to exchange the messages, right? So ultimately you can abstract away from process space and address space and physical hardware by saying that all that needs to happen is that object A may want to send some kind of message to object B, and then wait for response. And eventually, the response, again, there will be a way to provide the response, and the response will come back. So object A has to wait for that response somehow, find a way to basically put itself into a waiting state, and wait for that response to come back, right? So that's what we can formalize here, is basically say that we want messages, right? Messaging is basically the answer to basically to formalize exchange of information between the objects, right? So that type of interaction. So it can be another situation could be this, and that probably should wrap up our conversation today, is that object A, okay, object A over here, may want to communicate with object B, but object B does not exist. So object A has to basically leave this message that it wants to be delivered to object B in some kind of message queue, okay? In a message queue. So eventually object B will come to existence and will say, is there any messages there, right, in this queue? Basically you can even organize it this way, so that even when objects don't exist in the same time span, they can still exchange messages. So that would be also a very interesting situation to mention here in our conversation. So so lots of ideas, but from this point on, moving to the next week, we'll be focusing much more on basically practical application of all of these ideas, and looking at different scenarios, and of course looking at what we have to do with our semester project and so forth. So this is it. Keep paying attention to the handout, keep finding your partners, your teammates, and that's the direction in which we're moving. Thank you very much.